question is using the binomial distribution. And we can see that because we have the probability of success and a probability of fail. So we're going to write those down first of all. So the probability of a successful chocolate is 24 out of 25. And the probability of a fail, let's call this one success, is equal to 1 out of 25. And they're always independent. So yeah, we can see there that that is a binomial distribution. So in a batch of 20 chocolates, so n is equal to 20. They're chosen at random, and we want to find the probability that 2 of them are flawed. So for this one, we can see that x is distributed binomially, and we have 20 for our n value. The probability of success is actually the probability of fail here. It's the one we're asked about. And we want to find what happens when x is 2. We want to know what happens when 2 are flawed. So we're going to go to our calculator and we're looking at the distributions, and we want the binomial, and it's the PDF because we want an exact value. So it's 20 trials. This is 1 over 24. Oops, 1 over 24. The x value is 2. And we can see there that we have 0.153. Oops, it's 1 over 25, sorry. So this should be 1 over 25. So we can see there that we have to 3 significant figures, 0.146. And then for the second part of the question, more than 2 are flawed. So if we want the probability that x is bigger than 2, if you think of all the trials, we could have no flawed, 1 flawed, 2 flawed, 3 flawed, 4 flawed, 5 flawed, all the way up to 20 flawed. Now I'm interested in more than 2, so that means it doesn't include 2, it's more than, so I want 3, 4, 5, all the way up to 20. So I want everything except 0, 1, and 2. And therefore, the easiest way of working this out is to use the binomial CDF. So I'm going to go into binomial CDF, and I still have 20 trials. It's still 1 out of 25. And this time I want essentially 2 and less. So 2 and less. In which case I'm going to write 2 because it's the maximum value that you want to include and less than. And that gives me 0.956137. So I'm leaving that more accurate because then I want to do 1 minus that answer. And that gives me how many are the shaded yellow ones that I actually wanted in the first place. So 1 minus that, and I'm showing my working here, is equal to 0.0439 to 3 significant figures. So for the second part of the question, part B, it asks how much he makes. So he sells perfect ones for 50 and the flawed ones for 15. And it's if he sells 20. So the first thing to do is to find out how many do we expect in that 20 to be flawed or perfect. So 20 times 24 over 25, that will tell us how many we expect are going to be perfect. And 20 times 1 over 25 tells me how many I expect to be flawed. So if I work those out, so 0.96 is just 24 over 25. So I'm expecting 19.2 to be perfect. And I'm expecting, and again, 0.04 is just 1/25. So 0.8 to be flawed. In which case, we're going to sell the perfect ones for 50. So 50 times 19.2. And then we're going to add to that 15, which is how much I sell the flawed ones for. And that gives us a total of 972 pesos. And that's going to be his profit.